Hey, welcome back. Today we're looking at graph of a function. This stuff should be pretty easy. It's Algebra 1 type ideas. There's a little bit more sprinkled into it that kind of leads into calculus. But we're basically just looking at the graphs of a function and trying to answer questions. So if we're looking at this graph here, you might notice that as a sine function. If not, that's fine. It's just asking us what the values are for a, for f of 0, f of 3 pi over 2, and 3 pi. So all we're doing is our x here is 0. It's telling us what our value is there, so it'd be 4 for f of 0. 3 pi over 2 is here. That's 0. And then 3 pi is here. -4. Okay, what is the domain of f? Remember, domain represents our x values, right? The possible x values. So notice that there's no arrows at the ends. So there's an end point here and a start point there. So it goes from 0 all the way to 4 pi. Maybe we'll change our color here. Part C, what is the range? So range, if the domain is the x, the range is the y. So notice the lowest value of y, we have 2 points here that have the lowest value at -4. And the highest, we have 3 points, which is +4. So it would be from -4 to 4. Actually, these, right, because the points actually hit these points should be brackets, right? If they weren't including the points, if they got as close as possible to those points and didn't touch them, then we'd have to put parentheses. But in this case, we actually hit 4 and we actually hit -4. So we need to put our braces on those notations. Okay, so part D lists the intercepts. Recall that these are the points, if any, where the graph crosses or touches the coordinate axes. So let's kind of running out of room here. It's getting sloppy. So let's do this on the bottom. So D. So let's do the y-intercept first. The y-intercept is here. It's 0, -4. So the y-intercept is 4. The x-intercepts, we have multiple ones, right? We have 1, 2, 3, 4 different ones. There's one at pi over 2. There's one at 3 pi over 2. There's one at 5 pi over 2. And you see there's a pattern here that should be 7 pi over 2. Okay, part E, how many times does the line y equal 2 intersect the graph? So y equals 2 is going to be a horizontal line. It's going to cross through the y-axis at 2. So if we draw that line in there, we see that we have 1, 2, 3, 4 different points. So it crosses 4 times. Part F is asking us for what values does f of x equal -4. So that, remember that f of x is another way to say y. So when is y equal -4? It's equal to -4 at these 2 points. So that would be at pi and 3 pi. And then the last part is asking us for what values of x is f of x greater than 0. So be careful here. Like, you can get caught up in thinking about, oh, look at these symbols. What does that mean? It just means the function is greater than 0. So what line denotes where our 0 is? Let's erase all this stuff here. Well, we know it's equal to 0 on the x-axis, right? So all the parts of the graph that are greater than 0 are the parts above the graph. So we know it's from 0, and 0 is already positive, so we're going to include it, all the way to pi over 2. Right, all in this part. Then it stops, and it doesn't include pi over 2 because pi over 2 is actually equal to 0. So we have to put our parentheses here, right? And then it starts being greater than 0 again all the way through here. So it's going to be starting at 3 pi over 2 we're not including that point because it's actually 0 again, right? It's on the line. All the way to this point here, 5 pi over 2. And then it starts again at 7 pi over 2 all the way to 4 pi. So 7 pi over 2. Again, we have parentheses there because it's touching the line at 7 pi over 2. But at the end, at 4 pi, it's not touching the line. It's above the graph, so that point is included. We're going to put braces on there. Right, so if we were to do it in set notation, it'd be kind of messy. It'd be like... yeah, I don't want to touch it there. For this one, probably interval notation is better. Just remember this U's in the middle. They just mean that there's a gap in there. And then also, yeah, remember the inside points. If they're touching the axis, then these should all give us parentheses because they're not actually including those points. All right, let's look at the next one. So it's saying we're going to consider this graph. F of x equals x plus 1 divided by x plus 2. Now, we're thinking about what the graph looks like, but we're not going to actually draw the graph. So part A says find the domain. So remember what we did last time. We're talking about domain restriction. There's no square root in here, so we're not worried about that. But what we are worried with is if we have a 0 in the denominator, right? So we know that the bottom, x plus 2, cannot be equal to 0. And therefore, when we solve algebraically, x is not equal to negative 2. Okay, so the domain, we can write it like this, right? From negative infinity all the way to negative 2, not including the point because that would make it broken. It'd make the denominator 0. And then from negative 2 onwards towards infinity. Right, so that's in integral notation. In set notation, we'd say x such that x not equal to negative 2. Which is probably simpler, right? It's the simpler method for this one. Okay, part B. And this is just an algebraic concept. Is the point 1/1/2 on the graph? So if it were on the graph, if I substitute my x and my y, then it would come out equal. So let's check if it'll come out equal. So our y is our f of x. So we're going to say 1/2 equals, and we're substituting in for x. So 1 plus 1 over 1 plus 2. Well, that's going to be 2/3, which is not equal. So this is no. Right? If they came out equal, then we'd say yes, that the point is on the graph. Okay, part C. If x equals 2, what is f of x? So that's just basically asking us to substitute 2 for x. Tell us what our y is. So f of x equals 2 plus 1 over 2 plus 2, which is 2 plus 1 is 3/4. Pretty straightforward. D. If f of x equals 2, what is x? What point is on the graph of x? Oops, sorry, we should probably answer what point is on the graph of x for this one too, because it did ask us for part C. So then this is our y, it gave us our x, so it'd be 2, 3/4. Let's do the same for D. This time it's telling us that our f of x is 2, so it's going to be 2 equals x plus 1 over x plus 2. We don't like this x plus 2 in the denominator at this point, so we're going to multiply by x plus 2 both sides to cancel. And then we can distribute here. So 2 times x is 2x, plus 2 times 2 is 4, equals x plus 1. This is pretty simple algebra at this point. Move the x's together. 2x minus x is 1x. I might as well subtract the 4 at the same time. Equals -3. And that's asking us what point, so it'd be -3, 2. right? Because 2 they gave us for our f of x or our y. And then the last thing it's asking us is, what are the x-intercepts? So remember, x-intercepts are the f of 0, right? So, I mean, when f of x equals 0, I should say. So we're going to just say that the whole equation, the whole function, so let's kind of do this. So for e, when we're looking for x-intercepts, we're going to set f of x equals 0 or the y equal to 0. And then what we're going to do is we're going to go ahead and solve this. So we don't like this x plus 2 in the denominator either for this one. Sorry, kind of ran out of room. But then these cancel. 0 times x plus 2 is 0. And then we have to subtract 1. So x is negative 1. And it says what are the points on the graph of f of x? So that would be negative 1. And if we plug in negative 1 for our x, we end up with 0 because that's what we put in for our y. Okay. So pretty much algebraic stuff, just applying it to different types of functions that maybe you weren't used to using before. Please take your notes. Please make sure if you have any questions, come into class, ask them. I'm totally happy to help you out anytime you need it.